Our next proof, boys, is that we've got an external point P here, and we need to prove that if the tangents are equal, drawn to a circle, so the tangents TP and PW, that the line joining these points to the center, being OP, is the axis of symmetry. All right? So, in order to do that, you need to prove that PT equals PW. That's why I've highlighted it there. And we need to look at congruent triangles to achieve this. So the triangles we're going to look at is OTP and PWO. You should be able to see the red lines there, OT and OW. Now, because they're obviously radiuses of the same circle, they can be considered equal. The second part of the proof is that if you see that there's a little right angle symbol here, and what do we know? All tangents meet the circles at right angles. So far we've got a side and a radius. And now if you consider the two triangles, but they share which side? Well, they share OP. So that is a common side, so that is equal, but it's also a hypotenuse. So recapping, we've proved a radius, which is a side, we've proved a right angle, and we've also proved a hypotenuse. So therefore, those two triangles are congruent because of RHS, right side, hypotenuse, and a right angle. So therefore, you can conclude that PT equals PW, which was the purpose of the proof, and that's because these are the same sides in congruent triangles. And then finally, that proves that OP is the axis of symmetry of the two figures.